Hi there, I'm Brian Riley. I'm a TA for bio282, and in this video I'm going to be working with you through some of the basics of reading chemical formulas. We're going to look at several chemical formulas and try and work through them piece by piece, and along the way I'm going to encourage you to pause the video and work through some of these formulas on your own so that you get some practice with reading them. So let's start with this molecule. This is sarcosine. Sarcosine is a chemical that's commonly found inside muscle tissue and other bodily tissues. It's a byproduct of amino acid metabolism. But it contains 4 elements, that is 4 different kinds of atoms. There's hydrogen, there's carbon, there's nitrogen, and there's oxygen. And these atoms are connected together by covalent bonds, these solid lines here between them. And this is simply the sharing of 2 electrons between these different atoms. So it's really hard to draw this structure every time you want to draw sarcosine, or if you're thinking about some larger molecule, it becomes even more hairy. So chemists have come up with some shortcuts to save us a bit of time and ink. Here is exactly the same molecule, drawn in a simplified fashion. Both of these structures represent sarcosine. You notice that in the structure on the right, there are some things that we haven't drawn. For starts, we haven't labeled the carbons. We haven't drawn the hydrogens that are bonded to the carbons. And we haven't drawn the bonds between hydrogens bonded to non-carbon atoms. So here's another molecule for you. This is caffeine, the primary active ingredient in things like coffee and tea and soda. How many carbons are there in caffeine? Pause the video and see if you can figure this out. Remember, we haven't drawn the carbons, we haven't drawn the hydrogens bonded to the carbons, and we haven't drawn the bonds between the hydrogens bonded to non-carbon atoms. Give it a shot. If you said 8, you're right, and here they are. There's all 8 of them there, labeled. When you're hunting for carbons, generally a good tip is to look for what we call bends and ends. So bends are simply the places where 2 or more lines, 2 or more of these bonds, intersect. Ends are lines that don't connect to letters. And at these bends and ends, that's where your carbons are located. So another question. Here's a carbon out here on this end. How many hydrogens are bonded to this carbon? Pause the video again and see if you can come to an answer on your own. If you said 3 hydrogens, that's correct. We don't normally draw the hydrogens that are bonded to these carbons, but they're still there. A good rule of thumb is that carbons always form 4 bonds. How about this carbon, though? How many hydrogens are bonded to it? Pause the video and see if you can figure out on your own. So that was a bit of a trick question, actually. There are no hydrogens bonded to this carbon. You'll notice that this carbon already has a bond to this nitrogen over here, a bond to this nitrogen over here, and then it has this double bond between it and this carbon directly below it. So that already takes care of all 4 bonds that this carbon right here could make. So this is the end of this video. Thanks for watching, and I hope this has been helpful to you.